There we go. Recording counter started. So now we're moving on to talking about operating systems. This is going to be broad, like what with computer hardware and how computers work was. I'm not here to give you a sort of all-encompassing view of each of these topics. This is supposed to be a very, very general view, just to sort of give you an idea of the things that you might run into as a programmer. That being said, you should all be fairly familiar with Windows. Windows is the most commonly used desktop operating system on the market today. Um, and obviously, if you're writing software, you should make sure it works on Windows if you want it to get a lot of use. Um, One of the biggest things about Microsoft and Windows is that because of the breadth of devices that Windows covers, as we were just talking about with the whole NHS disaster, um, there's a lot of malicious software that gets written for Windows. Um, and there are a lot of good IT jobs out there that specifically deal with information security, um, that are designed to have you go out and look for these uh, mechanisms by which malicious software actually gets into a machine and takes it over. There have been uh, a lot of different iterations of Windows. Um, some better than others, um, but there have been a lot of different bits and pieces here and there. Um, just to list off a few, uh, starting off with what I really started off with was Windows 95, uh, which came out right around 1995. Um, and you go up from there. You've got Windows 98, 2000, Me, which stands for Millennium Edition, uh, XP, Vista, Windows 7, Windows 8.1, and Windows 10, which is what we're up to right now. Windows 10s coming fairly soon. Uh, I will say this: Microsoft's operating system up until this point, we haven't seen another operating system to confirm whether or not this is actually going to be the case. But Microsoft's operating systems alternate between garbage and great, for whatever reason. Um, like, let's take starting from Windows 2000. 2000 was okay. Me was terrible. XP was great. A lot of people still use XP for some reason. Um, Vista was garbage. Windows 7, great. So many people still use Windows 7. Even the state has a pretty significant portion of its fleet that's still Windows 7. Windows 8 and 8.1 went over like a bag of cats. Everybody hated Windows 8 and 8.1. And Windows 10 was slightly more well received than Windows 8.1, and people are getting used to Windows 10. That being said, there's not really much else that I can say about Windows here. So let's move on to Mac OS X. Now, you guys are probably fairly familiar with this simply because the MLTI program pretty much exclusively distributes, or at least up until a couple of years ago, they exclusively distributed Apple computers. They took the stance at the last contract renewal that if you wanted to have the state purchase a particular type of HP netbook, I believe, for your school, they could have done that, and it was a cheaper alternative. But they obviously didn't work as well. But Mac OS X, as with Apple's slogan, Think Different, is designed for people who want something different. Mac OS X and its interface is often considered very streamlined, and it's very well suited for creative productions like photo editing, uh, movie editing, creating music, what have you. But one of the biggest problems with OS X is that it's a very tightly controlled operating system. Apple doesn't really Apple really doesn't make it easy to run OS X on hardware that isn't theirs. And when somebody does get it working, it's usually not particularly stable, and it only works on very specific hardware. Apple doesn't like fun. Um, so it's one of those things where yes, you are paying a lot more, and probably a significant portion of what you're paying for is you're paying for the logo that you're buying. Um, but you also get a very nice interface, an operating system that's well maintained for specific hardware that Apple knows how to deal with, in a very stable environment that lasts a very long time, um, and is more than capable of holding its own against Windows if there were more applications written for it that are relevant to the business world. That's where Microsoft and Windows get a lot of their power, is that in the business world, Windows is where it's at. So that's sort of the bit of the toss-up there. And of course, that goes without saying that, we said Microsoft and Windows had a lot of versions. Apple and Mac OS X also have a stupid number of versions. Their OS X line of operating systems, up until very recently, followed the Big Cat lineage, which was very strange to me. Personally, I don't remember the exact order off the top of my head. I think it goes tiger, leopard, snow leopard, lion, and I think that was it for the big cats. No, cheetah. Cheetah came after lion, I think, maybe before tiger. I can't remember. And then then they started doing like places in California, I guess, which was Sierra, Mavericks, Yosemite. They just went full stupid with it.
This is the most recent one, El Capitan or whatever.
Yes, El Capitan is the most recent Mac OS X operating system, as far as I'm aware, which makes even less sense than the Big Cats thing, because I don't even know what these places are. At least I knew what the Big Cats were. So, I mean, of course it's arbitrary order, so if I tried to even learn the order of these things, it would now be even more difficult. But that being said, let's move on to our final operating system, and that's Linux. Linux, as it says in the slide, is the odd man out of the group. It's used in primarily servers and by power users who want to have a lot of control over their system. Conventionally speaking, Linux is a command line interface. It doesn't actually have a GUI like Windows, a graphical user interface, I should say, like Windows and Mac OS X does. And so that very low-level connection to the operating system and how it works is where a lot of its power comes from. There's a lot of freedom on a Linux machine to do really whatever it is that you want. That being said, if you want graphics on a Linux computer, you can, because there are a wide variety of different distributions or graphical user interface layers that you can put on top of Linux that will give you the ability to use it like a standard desktop or laptop operating system. Some examples of these are Ubuntu, Kubuntu, Xubuntu, XFCE, Fedora, Red Hat, OpenSUSE. I've got a list over here on this computer. Kali, JolieOS, Raspbian, which runs on Raspberry Pis, Debian. There are so many that they're just too many to list, and they all have their strengths and weaknesses. Like Ubuntu is geared towards your average user. It has a desktop interface that's fairly similar to Mac OS X. The interface is nice and streamlined, it's fairly easy to use, and it works like a regular desktop operating system. On the other hand, you have distributions like Kali, which is designed for network intrusions, breaking into somebody else's wireless or wired network.
What is that thing?
Normally speaking, Kali is designed for something called white hat hackers. They do intrusion testing on networks in order to determine open security holes on the network so that they can be patched. But obviously, Kali could also be used by black hat hackers, which are just trying to cause destruction, mayhem, and cost.
Have you ever done a black hat?
Have I ever done a black hat? There was one robotics venue that was not being very accommodating when we needed to grab a specific file so we could get one team up and running. So I did something called a brute force attack on their wireless network, which is basically just using a dictionary of passwords that are common passwords, and you keep testing it against the network until one hits, and then it lets you in. So, brute force attacks are probably the most archaic form of hacking that are available, but they work quite well because people are insistent on using passwords like password and 123456. So in many cases, it doesn't take very long to get in if you're going to use a brute force attack on an organization that really has no standards on password security. And even then, you'll still run into the occasional user that thinks, I'll just append another number to the end of my password, so it ends up being password 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, until they either hit the maximum length of the password and then they do something else, like switch to other letters, or what have you. But that being said, I do not condone you going out and trying to break into somebody's network. I also don't condone you going out and trying to break into somebody's computer either. It's an invasion of privacy. When you turn 18, you can be arrested. The final piece to this section is bit level and architecture. These subjects are a little bit tricky to cover in such a short time span. But for those of you that actually watched the video on installing the software, you probably remember me making a note of making sure that whatever bit level of Java you got matched whatever bit level your operating system was. And this is sort of the issue between 32-bit and 64-bit. The biggest thing about 32-bit versus 64-bit is memory addressing. That is, how many addresses we have in order to reference things in memory so that a computer can use them. Obviously, a 32-bit number can only store 32 bits worth of information, which means 32 bits worth of numbers, which, as computer technology has progressed, really isn't enough. In fact, if you have a 32-bit operating system, the maximum amount of RAM that you can have is about 3.23 gigabytes. The rest is just dead air, because your operating system or your computer, depending on your processor, can't actually access those memory locations because it doesn't have a number big enough to reference them. So that's where 64-bit processors and 64-bit operating systems come into play. They widen the number to 64 bits, which is a stupid number of memory addresses, which we will never touch, ever, ever, ever in our lifetimes. It would just be no. That make it possible for us to reference significantly more spaces in memory. It's basically a more efficient way of chewing through larger amounts of data faster. Right now, it's very rare, even on cell phones, to find a true-to-life 32-bit processor. 4 or 5 years ago, most cell phones and tablets were 32-bit processors, and there were still several computers out on the market that were pure 32 processors, although they weren't. They were netbooks and stuff. You really didn't want them to begin with. But nowadays, even phones are 64-bit processors because phones are starting to edge up into 3, 4, 6, and 8 gigs of RAM in order to be able to keep up with new operating systems, new features, new applications, and what have you. To try to sort of bridge the gap between what is a desktop and a laptop and what is a phone and a tablet. To try to bring them closer together, to try to make them perform the same tasks, just with different screen real estate. And then the other thing before we end this piece here is architecture. Intel, AMD, and ARM all have their different ways of building chips. And they all have their different ways of interpreting certain machine language codes into specific instructions that need to be performed. The big problem with this is that means that you can't really have an application written for one architecture that hasn't also been written in such a way that it can be moved to the other architecture. And what I mean by that is, and we'll talk about this a little bit more in a few minutes here, whenever you compile a program, whenever you take what we understand and turn it into something the computer understands, that code is being converted into machine language, ones and zeros. But your compiler, the software that actually turns it from what we understand to what computers understand, is smart. It will take code and interpret it down into the different pieces that are needed in order to make it work on specific operating systems and specific architectures if need be.
And that's why you mean like keywords like print line, right?
Print line is the higher area. When you say keywords, I think more of the specific assembly that our code gets translated down to, which is then further translated down into machine language. But that being said, the general idea of this is if you write something for like an Intel or AMD processor, which have fairly similar instruction sets, or you write something for Mac OS X and you try to run it on Windows, let's say, it's not going to work because they have different mechanisms for interpreting that along with different libraries and what have you. It's just not going to work. Another example of this is, I installed SketchUp on Tyler's computer, but if I wanted to install SketchUp on my phone, that's not going to work. A, because there is no version of SketchUp for ARM processors, and B, there is no version of SketchUp for Linux either, which is what Android is rooted in. Android is actually Linux-based. with that being said, this video is actually fairly close to what I want the length of the videos to be, which is about 20 to 30 minutes. So we're going to stop this one, take a moment, and then we're going to do the last 4 slides.